Welcome to the Authority Podcast, Plumbing and Mechanical. When talking about the built environment, we would do well to remember, we shape our buildings, and afterwards, our buildings shape us. Therefore, on each episode, we'll discuss the latest trends from IAPMO in plumbing and mechanical safety, sustainability, and resiliency. Join me, your host, Christoph Lohr, and together we'll explore the ways we can make our buildings shape us for the better. And welcome back to the Authority Podcast, Plumbing and Mechanical. I'm your host, Christoph Lohr, and joining me today is Stuart Bailin, Director of Engineering at Wahaso. Stuart, welcome to the show.
Thank you.
And Stuart, did I say that right? Wahaso?
Yes, Wahaso stands for Water Harvesting Solutions.
Excellent. And well, tell us, our listeners, a little bit about yourself.
Well, I've been involved in specialty treatment systems for dealing with corrosive chemicals, pH neutralization, and specialty processing my entire career, which spans more than 45 years. The last 20 of which I have spent being the Director of Engineering at Water Harvesting Solutions. And our mission at Wahaso is only water harvesting for reuse, with the intent to offset the use of domestic water by making more of it available, because we'll offset the use of potable water in applications like toilet flushing, cooling tower makeup, and irrigation being the big ones. There are other smaller reuse opportunities, but those are the big three. And I started doing this again about 20 years ago. 20 years ago, nobody was really thinking about doing water harvesting. Water was basically considered free and unlimited. And over the last 20 years, we've seen a big change, both in shortages of water being experienced, as well as conservation becoming much more common. But when I started 20 years ago, I had to spend a lot of time with regulators to convince them that harvested water was a safe reuse for non-potable applications.
Excellent. Well, and let's touch on that, kind of that 101 of water reuse. We've had a couple other guests on, but I think it's worth for our listeners to kind of maybe do a recap and a kind of a quick broad overview. What is water reuse? We've heard things like water recycling or reclaimed water. What's the right phrasing? Is there any kind of common uses and misconceptions? Just kind of the overall 101 on water reuse.
Sure, I'm happy to do that. Water reuse, again, with harvested water systems, we are not actually producing drinking quality water. While we have the capability of doing that, but typically from a legislative and also a legal liability issue, we do not do potable reuse applications. We concentrate on taking water from rainwater, groundwater, stormwater, condensate, and greywater, and clean it up, sanitize it, and make it reusable for common applications, being site irrigation, cooling tower makeup, boiler makeup, and toilet flushing. Toilet flushing being an application that's really only available in new construction, whereas the other opportunities can be retrofit opportunities as well. The key thing here is that a lot of local jurisdictions and states have specific rules that vary, and we must follow those. And the biggest issue that regulators face, of course, they're responsible for public health and safety, and they are very concerned about the systems that have been going out into the field. They don't know whether this is being built in somebody's garage or it was built in a legitimate, technically organized way. So the introduction of third-party standards relieves the health departments, the local health departments, from having to evaluate each individual system. If you're third-party certified, they know that your equipment has been through a rigorous testing and will produce water that will be safe for use with the general public.
And that's a great point about different states' approaches and looking at codes and standards, because that sets up well for my next question for you. There's some news about California recently making news about allowing wastewater to be recycled into drinking water. Here in my home state of Arizona, there's some bills that are going on to allow on-site greywater reuse, and a lot of discussion around on-site greywater reuse in particular. In your estimation, what codes and standards, and then also product standards, need to be in place to protect public health and safety when it comes to, let's say, on-site greywater reuse? We're focusing on that.
Okay, as far as reusing water, harvested, recycled water, there is a category of water called reclaimed water, and reclaimed water in the National Plumbing Code and also with IAPMO means that it's municipal. It's done at a municipal treatment plant, and they can take black water or gray water, whatever they have, and they will treat it up to a certain point. It's not treated necessarily all the way to be classified as drinking water, but it is processed up to a point, and then further on-site treatment can take that water and then make it healthy and safe for human consumption. The issue that is going to be with potable reuse of harvested water is one of legal liability.
Mm-hmm.
My personal feeling is that municipalities do a great job at creating drinking quality water, and that the harvested water should really be used to make more drinkable quality water available by offsetting non-potable reuse that wastes this high quality water where it doesn't need to be treated to that standard. As far as gray water categories, again, we talked about condensate, which comes from air handling units, rainwater. Stormwater is really rainwater that's hit the ground. And when rainwater hits the ground, it picks up a lot of sedimentation. It can pick up other contaminants like fertilizer, hydrocarbons, and the like. And so the treatment for stormwater is more robust than treatment for rainwater. Rainwater is water that's captured from the roof of a building before it hits the ground. And then gray water typically is water from showers, lavatory sinks, sometimes swimming pools, and in also certain cases it can be from laundry. There are different classifications of treatment of gray water, and they separate out laundry treatment from general bathing water recovery, bearing in mind that showers and lav sinks, that water already starts out as potable water. It has to be because it can be consumed by people. And so you're starting with water that's already of fairly decent quality, but it picks up detergent, it picks up hair. In the cases of laundry, it picks up lint. All of these things present challenges that must be adequately and efficiently removed in an automatic way so that the system can operate for long periods of time without going out of, down or requiring maintenance.
So, I mean, that's really great broad overview. And I think it really helps paint that picture, kind of a continuation of that overall context question. And one of the ones you brought up was, and kind of talked there, was gray water reuse. One of the things that I've seen, Stuart, is there's a lot of regulations that refer to NSF 350. But from my understanding, Stuart, there's some limitations on NSF 350. And this is a big reason why IAPMO IGC 324 was created. Now IAPMO IGC 324 is known as IAPMO ANSI Z1324. Can you help me and our listeners understand the difference in limitations of NSF 350 and why there was a need for an additional standard, and why jurisdictions should be thinking about the additional product standard of IAPMO ANSI Z1324?
Yes. Really excellent question. I'm going to go back into history. And 20 plus years ago, NSF 350 came out as a standard for gray water only. And because of this, we would get regulators contacting us, and they would say, we would like this rainwater system certified to NSF 350. And we would have to say to the regulator, we're sorry, we can't do that because NSF 350 is strictly a gray water standard. It doesn't apply to rainwater or stormwater or condensate or groundwater. So then they came back to us and they said, okay, well, make sure that the water is treated and the results are at least the same as it would be as if it were gray water. Not an ideal situation, but nonetheless, there it was. So about 5-6 years ago, IAPMO looked at this and said, we really should look at all sources of harvested water. So the standard applies to all sources of harvested water, with the exception of black water, which I can address separately. But we'll talk about rainwater, stormwater, groundwater, greywater, etc.
And condensate too, right?
And condensate as well.
Okay.
And so it applies to all those types of water, and it has a common treatment standard irregardless of what the source water is. The other major difference between how IAPMO approached this versus NSF is that NSF gave you a range that you had to be within. In other words, for gray water, you were allowed to have so much bacteria in the water, and you couldn't exceed. There was a high limit, and then there was an average limit that you had to be within. And regulators didn't like that. They were used to log reduction, and IAPMO took that approach to look at log reduction as far as how much bacteria, viruses, and pathogen reduction. And basically, they require a 4-log reduction, which is a 1/10,000th reduction in the number of bacteria colonies within a certain small sample, which happens to be 100 milliliters.
Stuart, is the 4-log reduction, is it fair to say it's like from what I'm familiar with, is like a 99.99% reduction? Is that?
I believe that is correct. Yes.
Okay.
So regulators were used to that, and regulators creating their own state standards. In particular, I'm going to talk about California Senate Bill 966, which was actually introduced a couple of years ago. Being in California and in a legislative matter, it takes a longer time than anyone ever imagined to bring this into effect. It was supposed to be going into effect in 2022. It is now going into effect in 2024. And the standard follows IAPMO limits. So they also looked at log reductions and say you have to have a 4-log or 99.99% reduction in the presence of bacteria like E. coli, coliforms, viruses, and then larger pathogens like Giardia, Cryptosporidium, Legionella, and things like that. The SB 966, when it does become a enforceable standard, which again is anticipated to be in the second half of this year, is going to supersede a lot of the other local requirements that different local jurisdictions had. So there's going to be more commonality within the state as to what they'll accept for a harvested water system and what they won't, as far as level of treatment. Now, one of the interesting things that has occurred is that a lot of cities and states have been moving away from NSF 350 because of its limited application. In other words, they want to see a standard that can apply to more than gray water, and they want to adopt the log reduction methodology as opposed to the range within that you need to be. Because of this, NSF now is revamping their standard. They're going to be going to log reductions methods. It remains to be seen whether or not they're going to expand it beyond just gray water and have it apply to all sorts of water. But they're being pushed in that direction because their standard is becoming out of favor, and the IAPMO Z1324 is becoming recognized. And that brings me to a comment I would like to make about third-party standards. And again, third-party standards means that somebody other than myself is telling regulators, I can tell them all day long how great my equipment works. they're not in a position really to evaluate that. In the olden days of what they would do is they would allow you to put a system in, but you had to test it for 6 months on site before you could reuse any of that water, which was tremendously expensive and also very wasteful. That you had to prove with each individual application that your system worked properly. With third-party evaluation and accreditation, it's been a big change for me. Fortunately, again, I had IAPMO certified lab in Ontario, California. They're an ANSI certified lab. They certified our equipment to both the IAPMO standard as well as NSF 350. It cost a little more to do that, but I'm glad I have both, because now if in some jurisdictions still recognize NSF 350, others recognize IAPMO, and in this way I'm covered that I have both.
So it sounds like you overall had a really positive experience with the IAPMO codes and standards, and then also with the IAPMO R&T laboratory.
Absolutely. I served on both the technical committee with IAPMO when the standard was being developed. I also was on the NSF committee, technical committee. And my experience with the IAPMO committee was very rewarding. And what I liked about the IAPMO is that they're very dynamic. They moved quickly and didn't drag it out, whereas with NSF, it takes them a much longer time to make changes because of the way they're set up to make changes. It just takes a long time. So that's why they're still struggling right now to update their standard, and IAPMO moved in comparison at lightning speed.
I'm glad to hear. One question on the 350 and the Z1324. One of the I guess, is there any difference in terms of building types? Because one of the things you notice in the naming of IAPMO Z1324 is it talks about multifamily, residential, and commercial buildings, and you don't see that. I don't think you see that in the naming of NSF 350. Is there any difference in terms of scope, in terms of building types that it can apply to the different standards?
Sure. NSF 350 has a small residential category, and then they have a commercial category, and it's defined by the volume of water that's processed on a daily basis. I don't recall what exactly the changeover point is. And in addition, they have a different category that allows you to do commercial greywater and laundry. So so they basically had 3 different categories. Unsure of how that's going to shake out in the future. As I said, NSF is being rewritten. I imagine that in the next year or so, we'll see how that lays out.
I appreciate that additional context, Stuart. So for our listeners, some of which include policymakers and design professionals and others, I mean, can you tell them, in terms of including IAPMO Z1324, in their regulations or in their specifications when they're doing a project, what's been your experience, from the engineer, the manufacturer, and the policymaker standpoint in terms of benefits of applying IAPMO Z1324 to any greywater or other water reuse efforts?
Sure. IAPMO 324, well, I should call it 1324. I'm sorry. I always refer to it as 324. 1324 is a much broader scope, has a much broader scope in that it accounts for all kinds of harvested water types, and again, with the exception of black water. And I suppose this might be a good time to just mention black water. There are some people who are looking for zero discharge on their properties, and it's primarily, we've been seeing it in Northern California. Mm-hmm. Personally, I'm thinking that if you have access to a municipal sanitary sewer, that to me makes a lot more sense than to have it at an individual building level. But there are still, people looking to do that. And the issue there is that black water, being human waste and food waste, much more dangerous if you have an upset condition. You still have to have a connection to the sanitary sewer anyway, for exactly that reason. That if you're in building black water treatment system stops working properly, they're going to switch over to the municipal. I just personally don't think that black water makes a lot of sense, but that's just my personal opinion. But from a regulatory standpoint, IAPMO 1324 has a much broader range, and the measurement methodology using log reduction is very important, I think, to regulators. It more resembles what they do in wastewater treatment. They're used to looking at those kinds of standards. So I prefer I prefer that type of a standard, and I think regulators around the country that we've been working with also feel the same way.
So is it fair to say, I guess, from the kind of going through the thing from a policymaker standpoint, by adopting IAPMO Z1324, they would be streamlining the permitting process and reducing regulatory burden?
Absolutely. One thing I would like to mention to any regulators that are listening is regulations are great in requiring a third-party certification process is also great, but one of the things you need to include in your standard is annual review and testing, because there have been situations in certain states where they put this into effect, but there's no policy regarding annual confirmation that they're still using the system. And some builders may look at putting in this type of equipment as just a fixed cost for doing, as part of building their building. And once it's, they got their permits, if there's no review in the future, they're just going to shut that system off. And then you're kind of not getting the benefit of, recycled water and the benefits, because the building owners don't take it seriously, because it's, as I said, it's a cost of doing business.
No, in many respects, that what you're describing sounds very similar to like backflow prevention inspection, like annual checkups or certain yearly increments of periodic testing of backflow preventers that are on site to make sure they're still working.
Exactly.
And any codes or recommendations or standards worthwhile for them to consider to make that mechanism take place?
Well, I think there needs to be a penalty for not maintaining the system. And it has to be something that has some teeth to it. One of the other, I deal a lot with regulators, and one of the big problems that they have is manpower. And a lot of them say, we just don't have the manpower to go. And as more and more of these systems are put in, we don't have the manpower to check to see whether they're still operational, 1, 2, 3 years later. But
no, that makes sense. Stuart. So kind of continue that line of questioning. So we talked about from the policymaker standpoint, from the engineer or the installer, so the plumbing design professional or the installer that is putting together the system, the plumbing installer. What do you does adoption by a jurisdiction of IAPMO Z1324 make their process a bit easier in terms of trying to design and install these types of systems?
It's really a good question. I'm not sure I know the answer to that question. One of the, as a manufacturer of this type of system, holding third-party certifications, I found it to be a huge benefit.
Okay.
Because it shows up in the regulations. For example, we've been talking a lot about California, but let's look at, say, Washington, D.C. area. They also have enacted a standard, and it does require not a certified system, but it does require that you accumulate a certain amount of log reduction credits, and by the different types of treatment that you use. So it does closely resemble what you have to do to get a third party certified without saying you have to have a certified system. However, the regulators know in that area that Wahaso makes a certified system and it meets their local code requirements. So they just say, okay, you're certified to IAPMO 1324. That meets all or exceeds the requirements that we have. We'll use your system because of that. Because we don't have to worry that when it goes to plan check, that they're going to get a kickback.
Yeah, that makes sense. And so I think from my experience as a plumbing design professional, as a professional engineer, standards really made my life a lot easier in general. Because if I could put in my specification, like, hey, whatever this number is, for this particular product, and then in the shop drawing review stage, I saw that it matched up. I had a much higher degree of confidence that the system would work instead of having to double check each individual component. So, and it sounds like what you're saying is really that having a standardization, that like a standard like IAPMO Z1324 for your products really leads to a lot of growth because it helps standardize your process and it makes things easier for your clients and your customers.
Exactly.
Ultimately.
Yeah, it's been a tremendous. I mean, it was. I will admit that it's not inexpensive to get your equipment certified. It's not cost prohibitive, but it is. There's a significant investment both in time and money to get there. But the rewards have greatly outpaced the time and effort to become certified.
So you've seen some growth in your business then, Stuart?
Absolutely. It was one of the best things that we did as a manufacturer, going above and beyond, making it easier for us to sell our product in various markets. It also, to clients, gives them some warm and fuzzies that they're dealing with, a real company quality, supplier of equipment.
Definitely. Stuart, I would say from my experience working with some very seasoned plumbing design professionals, whenever there was a new product on the market, there was a bit of, you can make an argument, healthy or unhealthy skepticism. I think engineers tend to be very conservative, very risk concerned. And so from my experience working with those engineers, I think what you point out just now is very poignant. And that is, when they see that third-party standard, there's an additional amount of confidence that's gained because it is a third-party testing methodology. So it sounds very similar to my experience in that regard too. Well, as we wrap things up here, Stuart, I want to ask you one last question, and that is, I would absolutely love to have you back on. I have learned so much from you here during our time here together on this podcast. The next time I have you come on, whether that's in a year or a few months or next couple of years, what do you think we're going to be talking about?
I think we're going to be talking. That's a really thought-provoking question that I cannot easily answer. But I think we're going to be talking about that the industry is and acceptance by regulators and health department people is going to grow. I think what we're going to see is that the size, because I'm seeing it now, that the size of the treatment systems is growing. It used to be if we did something that treated 50 gallons a minute to 100 gallons a minute was the norm. I'm seeing applications now where we're doing systems over 500 GPM treatment systems. So 10 times the initial size that I was doing when I started this 20 years ago. So, the technology is growing. We've been able to refine our equipment to meet this growth. And as I said, we're going to be seeing systems that are more sophisticated in their monitoring and self-monitoring. They're going to have to be able to run independently of a person stationed there to do that, which we're already there. I mean, both the IAPMO standard and the NSF standard require that these systems be robust and not require intervention. For example, during our testing, we had to run our system for at IAPMO Ontario lab. We ran it 11 hours a day, 5 days a week for 6 months.
Wow.
because the NSF required 6 months, IAPMO only required 3 months of testing. But one of the key things is that the system had to be robust enough that it would not require any, first of all, that we didn't have any unplanned shutdowns where the system went offline. We didn't have any. We ran more than 3 million gallons of greywater through the system during that time period. And there was a planned shutdown, and the system would be shut down to mimic what would happen if there was a power failure. And then when the power was restored, could the system automatically reboot itself and start up itself and run independently? I think all these things are going to become increasingly important, that these systems be very robust, handle larger volumes of water, and be able to do that without direct human monitoring intervention on site. Remote monitoring is already growing, and it's going to be going in that direction.
Fantastic. So it sounds like you're also sort of saying that you're expecting, anticipating more growth for IAPMO Z1324 as well.
Yeah, I do.
Well, on behalf of the Authority Podcast, Plumbing Mechanical, and IAPMO, Stuart, I just want to say it was an absolute pleasure speaking with you this morning. Thank you for taking time out of your busy schedule to talk with me, to teach me and our listeners, and just sharing your expertise and insights.
I appreciate the opportunity. And again, it was a pleasure. Thank you, Chris.
Thanks for joining us on this week's episode of the Authority Podcast, Plumbing and Mechanical. Love this episode of the podcast? Head over to iTunes to subscribe, rate, and leave a review. Please follow us on Twitter @AuthorityPM, on Instagram @TheAuthorityPodcast, or email us at iapmo@iapmo.org. Join us next time for another episode of the Authority Podcast, Plumbing and Mechanical. In the meantime, let's work together to make our buildings more resilient and shape us for the better.